Hello and welcome to lecture series on electrodynamics. We are doing product rules. We know for the ordinary derivatives, we have sum rule for the derivative. And if we have two function f and g and we want to take derivative with respect to say they are function of x. So we have f of x and g of x. So we can write df over dx plus dg over dx. And we have the rule of multiplication of a constant. Of constant. So if you have d over dx and we have k constant and then f is a function of x, then k df over dx. So the constant can come out from the derivative. And we have the product rule. If we have product of two functions, say f and g again, so d over dx fg is equal to f dg over dx plus g df over dx. And the last one is the quotient rule. And the quotient rule is if we have function f and g, but f divided by g, so we have g df over dx minus f dg over dx divided by g square. So we have these four rules for differentiation when we have ordinary derivatives. So these four rules can be extended for the vector differentiation. So again, if we start with the product rule, with the sum rule. So for sum rule, we will have say one sum rule. We have three different type of vector derivatives. So for everyone, we have to apply the product rule. So the first one is gradient. Gradient of two vector function, two scalars functions is del f plus del g. Similarly, we can write, say we have two vectors and a and b. So the sum rule is del dot a plus del dot b. And third type of vector differentiation is del cross, where we have a cross b So I have two vectors, a plus b, sorry. So for del cross a plus del cross b. Similarly, we can apply the constant rule for all three type of vector differentiation. So 2 we have a del kf. It will turn out to be k del f, and b is del dot ka, where k is again a constant, so we will left with del dot a. K will come out. And third is del cross k, and it turned out to be k del cross. And similarly, we can work out the product rules. And third is product rules. So, but we have two scalar products. So we have FG, which is two scalars product, and a scalar, and we have a vector multiplication which return a scalar, and then we can have two vectors. F is this a function, this is a vector product, and we have a cross b. So there are four different type of products. So if we apply the differentiation, vector differentiation, which is delta, so we have to work out all four options. So say we want to work with first one, so it will turn out we have two or scalar ones, so we have two options to work on. The first one is del fg, and it turned out to be g del f plus f del g. Likewise, we have scalar a dot b. We can take the gradient of the scalar function. So it turned out product of a cross del cross b plus b cross del cross a plus a dot del b plus b dot del a. This is a lengthy formula, but we will not be using too much. This if it's needed, it's on in the front cover on the book, and we always can revisit. Similarly, we have two vectors. For two vectors, will have two. We can take two divergence and two curls. So for divergence, we have del dot fa, where both are functions. One is vector function, one is scalar function. So it turned out f del dot a plus a dot del f. And divergence, we have another vector quantity, then then we can take divergence. This is a vector quantity A cross B, and the divergence is B dot cross A minus A dot del cross B. Similarly, we have two products for cross. So we have del cross FA, F del cross A minus A cross del F. And the last is del cross A cross B. And it can be written as del cross B dot del into A plus A to del dot B minus B del dot A. So again, all these are available on the book cover, and if you want to prove the proofs are also straightforward. We can work out one example, like if we have del dot f. So it turned out to be partial over partial x f ax plus partial over partial y f a y plus partial over partial z f a z. And if we apply the product rule on every component, then we have ax partial f over partial x plus f partial a x over partial x for first one. Similarly, for y component, we have ay partial f over partial y plus f partial ay over partial y. And same goes for z component, az partial f over partial z plus f partial az over partial z. So if we combine the first and second with the dot, then we can write this thing like partial f over partial x and then we have partial f over partial z. We took f partial f over partial x common in from here, and dotted with, it's still the first part, so dotted with ax x y plus az z. Then we have plus, and if we take all three, the second part, then it will turn out to be f out, then it is partial ax, partial x, then partial ay, partial y, partial az. So this thing is del f dot a plus this is f del dot. So that's what we have in the formula. If we see f del dot a plus a dot del f. So all the formulas can be proved this way. And the last was the quotient rule. So quotient rule again can be have all three options: gradient, divergence, and curl. Divergence of A over G del dot A minus A dot G divided by G square, and the cross of A over G del cross A plus A cross del G divided by G square. So all these relations can be proved easily using component form. So if you have any question, you can ask me in the comments. See you in the next lecture. Bye.